Today we are going to solve one-step inequalities. You can solve inequalities by using the addition property of inequalities and the subtraction property of inequalities. When you add or subtract the same number from each side of an inequality, the inequality remains true. An inequality is a mathematical sentence that compares quantities. Solving an inequality means finding values for the variable that make the inequality true. The table to the right gives some examples of the words you might use when describing different inequalities. So you can pause and take a look at those words. The ones that I want to focus on are less than, which is this symbol, greater than, less than or equal to, and greater than or equal to. And those are what the symbols look like. We're going to solve one-step inequalities the same way we would solve one-step equations. So here we have our first example, x plus 3, that symbol is greater than, so we would say x plus 3 is greater than 10. We're going to draw our line, this time through the inequality. We don't have an equal sign. In order to get x by itself, I need to remove this plus 3. I do that by subtracting 3. My 3's cancel. I am left with x on that side, and 10 minus 3 is 7. Now, instead of bringing down an equal sign, I bring down that symbol, that greater than symbol. So this means x is greater than 7. So any number bigger than 7 is in our solution. So here's how we graph it. Now, if we look back up at this chart, and I want you to go back up there as well, we have the greater than symbol. A greater than symbol is represented by what we call an open circle. Similarly, a less than symbol is also used with an open circle. These ones over here, less than or equal to and greater than or equal to, these are actually colored in, or a solid circle. And here's why. It's because they include the number. Okay? Another way to look at it, do you see how there's this little line on the bottom, that equal to part? That's what makes us remember to color in our circles. So here's what I mean when I'm talking about these circles. So we have a number line from going back to A. The number that we got as part of our solution here was a 7. I want you to put that number in the middle of your number line. Now it's a number line. We read left to right. So 1 fewer than 7 is 6, and 1 more than 7 is 8. So our number line is 6, 7, 8, with 7 being in the middle. And again, we chose 7 because of this solution. So we have a greater than symbol, which tells me I am going to draw an open circle on the 7. Now, we want a number that is greater than 7. Is 6 greater than 7? No, it's not. Okay. Is 8 greater than 7? Yes. So 8 is part of our solution. So what we do is we're actually going to draw an arrow to the right, because that's where the 8 is. So any number to the right of 7 is considered greater than 7, which means it's part of our solution. So that is how we graph an inequality. Okay, so let's take a look at letter B. We're going to draw our line down through the inequality symbol. I'm actually not going to draw it that long. There we go. My variable's on the right-hand side. I have n minus 5. To get rid of minus 5, we add 5. Negative 6 plus 5 is negative 1. Bring down that symbol. Those 5's cancel out. And we have negative 1 is greater than or equal to n. So negative 1 is greater than or equal to n. All right, so if we take a look at our little chart up here, the greater than or equal to symbol has a closed circle. So let's keep that in mind. On our number line, we're going to make sure we include this -1 in the center. If I'm going smaller than -1 to the left, that would be -2. So -2, -1, the next number would be 0. So again, I discussed a closed circle on -1. That takes care of our circle. Now, our choices that we have are -2 and 0. So let's see. If I replace this n with a -2, and then I also replace it with a 0, we got to figure out which one of these is true. Is -1 greater than or equal to -2? I know negatives are a little tricky, but if you take a look at your number line, any number that's on the right-hand side is the larger of the numbers. So if we look at our number line, -1 is greater than -2 because it's to the right. So this is true, okay? Which means this one can't be true. So -1 is greater than or equal to -2, which means we're going to draw our arrow to the left this time. And that would be letter B. Let's take a look at letter C. A minus 3 is less than 8. So we're going to add 3. 3's cancel. I get A is less than 11. 11 goes in the center. 10 is 1 less than 11. 12 is 1 more than 11. We're using the less than symbol, which is an open circle. Okay? So the question is 10 less than 11? Again, I'm replacing the A. Or is 12 less than 11? Well, 10 is less than 11. 12 is not. So because 10 works, we're going to shade to the left. Okay, let's keep going. Letter D. We're going to subtract 4 from both sides. 4 minus 4 is 0. Less than. These 4's cancel. And I have 8. So this one's a little weird. We have a 0 as a solution. Or I shouldn't say as a solution. We have a 0 as part of our solution. 0 goes in the middle. 1 bigger is a 1. And 1 smaller is a -1. It is the less than symbol, which means it's an open circle. And then we have to replace this H with our two choices. We have -1 and 1. Is 0 less than -1? If you look at your number line, 0 is actually bigger than -1 because it's to the right. So this one is not true. 0 is in fact less than 1. Since 1 is part of our solution, we shade to the right. Letter E. We're going to add 6.5 to both sides. We get x is less than or equal to 10.5. So 10.5 goes in the middle. 1 more is 11.5. 1 less is 9.5. You also could have, if you wanted to, use the numbers 11 and 10 if you wanted to count by halves, but that's not necessary. It is a closed circle because it's less than or equal to. Let's plug in our two numbers for x. 9.5 less than or equal to 10.5, or 11.5 less than or equal to 10.5. 9.5 is less than 10.5, so that's the way we shade, to the left. Letter F. A plus 1/2. So A is on the right. To get rid of our plus 1/2, we subtract a half. What we end up with is 1.5 greater than A. So 1.5 is our middle number. Again, you can just say 2.5 and 1/2, but let's change it up a bit. 1.5, my next whole number would be 2. If I went down, it would be 1. So this is an example of how we can also count by halves. We don't have to count by ones on our number line. It's a greater than symbol, which tells me it's an open circle. So let's go ahead and plug in our two numbers. We have a 1 and we have a 2. And again, I'm getting these numbers from our number line. Is 1.5 greater than 1? Yes. It is not greater than 2. So since 1 is part of our solution, we're shading to the left. All right, let's switch gears. Let's talk about multiplication and division. The multiplication property of inequality and division property of inequality state that an inequality remains true when you multiply or divide each side of an inequality by a positive number. Here's the key, though. When you multiply or divide each side of an inequality with a negative number, the inequality symbol must be reversed for the inequality to remain true. So let's keep that in mind. Okay. So I have 8 times x is less than or equal to 40. To get rid of multiplication, we divide. We get x is less than or equal to 5. It's less than or equal to, so I know there's a closed circle on 5. So let's put 5 on our number line, a 6, and a 4. Closed circle on 5. Is 4 less than or equal to 5? Or is 6 less than or equal to 5? Well, 4 is definitely less. 6 is not. So that tells me we shade to the left. Next one. D divided by 2 is greater than 7. To get rid of division, we multiply, and we get D is greater than 14. 14 in the middle, 15 to the right, 13 to the left. I know it's an open circle because it's greater than. Let's plug in our values. Is 13 greater than 14, or is 15 greater than 14? 13 is not greater, but 15 is. Since 15 is part of our solution, we're going to shade to the right. Letter C. 4 times x is less than 40. Divide by 4. X is less than 8. 8 goes in the middle. 1 up is 9. 1 below is 7. The less than symbol tells me it's an open circle. So plug in our numbers. Is 7 less than 8? Or is 9 less than 8? 7 is less than 8 and 9 is not. Since 7 is part of our solution, we shade to the left. So now let's take a look and see what happens when we have a negative number that we're dividing or multiplying by. When this happens, we're still going to solve it the same way. We're going to divide by -2. But here's the tricky part. This symbol has to be reversed. We flip it. So now instead of less than, it becomes greater than. 10 divided by -2 is -5. So -5, one smaller is -6, one larger is -4. It is an open circle on -5. So let's plug in our values for G. Is -6 greater than -5? Or is -4 greater than -5? Remember, the bigger numbers are always going to be to the right on the number line. We want something bigger than -5. -4 is bigger. So this one is correct and this one is not. Because -4 is bigger, we're shading to the right. Letter E. X divided by -3 is less than or equal to 4. To get rid of division of -3, we're going to multiply both sides by negative 3. Those cancel, leave me with x. 4 times negative 3 is negative 12. Because we are multiplying by a negative number, we also have to flip that inequality sign. So it was less than or equal to, and now we're going to change it to greater than or equal to. Just like in the previous example, because we divided by a negative. So anytime you multiply or divide by a negative, you have to flip that inequality symbol. Okay, so negative 12 is our middle number. 1 greater is negative 11, and 1 smaller is negative 13. It's greater than or equal to, so it's a closed circle. And let's plug in our values. We have negative 13 greater than or equal to negative 12, or negative 11 greater than or equal to negative 12. Remember, the bigger number is always on the right, on your number line. We are looking for a number bigger than negative 12, and negative 11 is that number. So this one is correct. This one is not, which means we shade towards negative 11. Okay, last one. Again, we're dividing by a negative 2. To get rid of it, we multiply by negative 2. Those cancel. K on the left, 9 times negative 2 is negative 18. Again, because we're multiplying by a negative, this symbol must flip. It was less than, it now becomes greater than. Negative 18 goes in the middle. Then we have negative 17 is bigger, negative 19 is smaller. It is an open circle because of that greater than symbol. Let's plug in our values. Is negative 19 greater than negative 18? Or is negative 17 greater than negative 18? Again, the larger number will be to the right on a number line. We are looking for a bigger number. So here again, this one is correct. This one is not. So we shade towards the negative 17.